Every building has two versions. The first is the one everyone notices immediately. The architecture, the finished space, the seating layout, the overall form. The second version is quieter. It sits above ceilings, behind walls, around beams, inside service zones, and across every part of the building that has to actually function once construction begins. That second version decides how smooth the project really is. In this model, both versions start coming together. At first, this feels like a simple walkthrough. We move around the building, step inside, and get a clear sense of the auditorium and interior layout. The model reads like a finished design environment. And that is usually where most people stop looking. But for project teams, this is often where the harder reading begins. Because once the space is understood architecturally, attention shifts to everything that must fit around it. Structure, mechanical systems, electrical services, plumbing routes, access zones, clearances, support conditions, installation logic. The visible project may already look settled. The hidden project is still being tested. That is why coordination matters so much. A building is never made from one complete idea. It is assembled from multiple systems that are often developed separately and then expected to work together in one real construction environment. The process is exactly this. Architectural, mechanical, electrical, and plumbing elements are developed separately and then brought into Navisworks for coordination. And that is where the model becomes more than a model. It becomes a conversation between disciplines. One system asks for space. Another already occupies it. A third depends on the route staying open. The building begins revealing whether all those decisions can coexist without tension. This is what makes a coordination platform useful in practice. The model can be read layer by layer. As elements are hidden and isolated, the building starts exposing its internal logic more clearly. It is a different kind of viewing. Not, how does the building look? More, how is this building going to hold, route, connect, and install? That is where the model becomes genuinely useful for teams. The auditorium is a good example. At surface level, it is a finished space with seating and interior definition. But spaces like this are usually doing much more work than they appear to be doing. They have to accommodate services, structural conditions, and coordination decisions that may not be visible in the first pass through the model. That is why projects can feel resolved on screen and still carry unresolved pressure inside them. A ceiling zone may already be crowded. A service route may already be tighter than it looked in isolation. An apparently minor overlap may later affect installation sequencing. The model starts revealing these things only when all disciplines are brought into the same conversation. As we move toward the MEP side of the project, that becomes easier to see. The ducts, pipelines, grills, and structural framing begin sharing the frame at the same time. This is where coordination becomes less abstract and more practical. Because at this point, the question is no longer whether each system was designed properly on its own. The question is whether they remain workable once the building asks them to live together. That is where Clash Review earns its value. Not as a flashy software function. As an early warning system for the project. The operational point is clear. When issues are identified in 3D early, a large share of field problems can be resolved before execution begins. This is also where the difference between authoring and coordination becomes important. The modeling itself is done in Revit, while Navisworks is being used here for viewing, coordination, issue review, simulation, clash detection, and quantification. That makes sense in a real workflow. One environment develops the design. Another helps test its readiness. And that readiness is not just technical. It affects field clarity, sequencing confidence, and how many surprises are allowed to survive into construction. What makes this kind of model valuable is not only that it helps teams see the building. It helps them see the parts of the building that usually stay hidden until they become a problem. That is where coordination begins to influence the quality of execution. By the time a project reaches site, every unresolved overlap demands more attention, more adjustment, and more time than it ever did in the model. Reviewing that pressure earlier gives teams a far better chance of entering construction with clearer decisions already in place. That is often the difference between a project that simply looks complete and one that is actually ready to be built. What coordination ultimately delivers is not just clash-free models, but more predictable construction outcomes. Each resolved intersection reflects a decision made earlier, when the cost of change is lower and the impact of that decision is easier to manage. In complex environments, conflicts are rarely isolated. They affect routing logic, installation sequencing, access zones, and long-term maintainability. BIM coordination becomes less about detection and more about delivery readiness. It allows teams to test spatial feasibility, validate system coexistence, and reduce uncertainty before execution begins. Poor interoperability has been estimated to cost the U.S. capital facilities industry $15.8 billion annually, which is exactly why coordination cannot be treated as a secondary exercise. At Tejjy, we help project teams turn coordination into confidence, complexity into clarity, and design intent into buildable reality. For stakeholders who carry the pressure of timelines, coordination, and execution, Tejjy Inc. helps bring more certainty before your construction begins.